Actually, it's a beautiful day here in Manchester, which is very uncharacteristic. I can just see a Ryanair jet taking off. We're right on the end of the runway here, and I think we are just about on time to start. If I look at my schedule, it's 2 o'clock now. So let me introduce today's webinar for you. As very privileged to present our webinar team for today. The Venerable Mr. Tony Smith, world-renowned inventor of the PAPI. Thank you, Tony, for joining us again. It's always a pleasure, and I always hugely value your knowledge and advice and help and support in everything we do. Keith Costill will be presenting today on today's topic. Again, another world-renowned expert in his field, number one airfield lighting trainer, and the most knowledgeable person when it comes to all of the standards and the issues and challenges that we face today. So Keith will be doing the presentation. Stuart Ford will be joining us later, an independent consultant based out of Connecticut in North America. Again, very well known, particularly to our North American colleagues. I met him recently at the IES conference and is now the representative of the IES committee that works closely with the FAA in terms of policies and procedures and developing new advisory circulars. And then, of course, myself was managing director of TMS, Tailor Made Systems, and who design and manufacture the MARMS suite of products. So without any further ado, let's kick off today on today's topic. This has been raised as a number of issues. Indeed, I've had it just today in meetings at the airport. It is very difficult for a lot of us to do our jobs. We're all tasked with delivering compliant airfield lighting, but we can't do it. Without getting on a runway, and it's very, very difficult, particularly now COVID has largely gone away. Touch wood. It's very, very difficult to actually get the runway access necessary to perform the very vital work we do, maintaining airfield lighting on visual aids generally. So, so today that's our topic. We'll talk about the tips and techniques as to how we can actually get this job done in an ever more challenging environment. So I'll now hand over to Keith.
Okay, thank you very much, Robert. I hope everyone can hear me. If you cannot hear me for any reason, or you've got any questions, etc., please use the Q&A and type in your questions. We're going to be a little interactive for this presentation, where I will ask Robert to join in and Tony to join in, and hopefully when Seward arrives, he's traveling at the moment, so it's hopefully we'll get on online. So anyway, let's kick off on this subject of can we actually do our work? How do we get access, etc., to do the maintenance we would love to do? When there are issues, whether we are doing routine maintenance or breakdown maintenance or whatever, access is always an issue. Now, it's very interesting, this slide, and I will ask Robert to move the slides on, because he said that this is being presented online from Manchester International Airport, so he is in charge of the slides. The US Department of Transportation Secretary Ray LaHood said we put rules in place and regulations in place to keep the flying public safe. Therefore, we expect operators, the airfields, to perform inspections and conduct regular and required maintenance in order to prevent safety issues. And we always say there is no compromises at all when it comes to safety. Safety is non-negotiable, and it's as simple as that. We've just pulled out a few little statements that are relevant. ICAO, the International Civil Aviation Organization, defines competency, that's us as people, as a combination of skill, knowledge, and attitude. Attitude, big issue for us, you know, because who really wants to be out on a cold, wet, dark, overnight runway to perform maintenance? So we need to have the skill, the knowledge, but we certainly need to have the attitude to be required to perform the prescribed standards that are expected of us. And very interesting, Richard Branson made this comment, and I think that's very, very good. Train your personnel well enough so they can leave, but treat them well enough so they don't want to. Very, very good. And ultimately, if we look at the commercial side, and when we're looking at, and this is something that we will discuss during this presentation, is you think maintenance and training is expensive, try an accident. So why do we actually need compliant visual aids? Remember, most of our in our digitalization world of today, AI, you came it, call it what you like. Do we still need to have a pilot? Yes, we do. Right? We need to have that human being there. So that human being and needs to have a visual indication that they are safe to operate. So that's why we need to have compliant visual aids. It's mandatory. So operationally and regulatory. So operational is safe aircraft operations, naturally. Regulatory are the standards and the recommended practices. So let's first look at the operational side. Pilots need to know visually if the visibility in the final stages of the approach, so that they're not going to hit any obstacles in the approach area, along the runway, and during the transit to and from the runway. So it's not just the runway. Remember, we have the runway facilities, which includes the approach, and we have the taxiway facilities. So, or we need to have visual cues, visibility during that. So it's adequate to permit a safe aircraft operations. And the objective of the visual aids is to provide those visual cues so that we can operate safely and regularly under all the specified conditions, because there are specified visibility conditions that we have to consider. On the regulatory side, we have the standards. We have the standards and the recommended practices. Now, the standards are clear. It is mandatory on the standards. Now, to meet those mandatory standards, then we have a whole range of recommended practices. And when we're looking at our recommended practices and our standards, then we're looking at non-instrument facilities, we're looking at instrument facilities. In today's passenger carrying, in the cargo world, etc., most of our main airports are instrument facilities. And there are three main categories, because we, as the visual aids, supplement the instrument facilities that are available. So let's have a look at these categories. So we have, on an instrument runway, we have an instrument runway, which is a precision. So we have non-precision facilities and we have precision facilities. Now, interesting, in more recent times, then we had the category 1, the category 2, the category 3, A, B, and C conditions. Now we fundamentally have just what category 1, category 2, and category 3, whereby in category 1, then it is when the visibility is greater than 800 meters, or the runway visual range. And what does that mean? Runway visual range means that when that aircraft is on the runway, how far can the pilot sat in his or her aircraft see the visual aids down the runway? Runway visual range. So when we're looking at runway visual range for Cat 1, that is greater than 550 meters RVR. If the visibility drops below the RVR of 550 meters, then that's category 2. and between 550 meters down to 300 meters, because if it drops below 300 meters, RVR, that is category 3. Now, interestingly, when we go to those lower visibility conditions, for example, category 2 and category 3, and what will happen is that when we're looking at our lighting system, then can we see our lighting system, and how long before we see the lights at the speed we're traveling at? How much time have we got to react? And they're the key issues for operational safety. That is why we have the Cat 1, Cat 2, Cat 3 considerations, and our visual aids are installed and commissioned and operated according to that. And we have the different types of instrument approaches where we get type A, B, C, etc. So that's the kind of standards that we and the recommended procedures that we have to consider. Now, ICAO in Annex 14, now there are 19 annexes in ICAO, which are all standards that's mandatory to achieve. And then there is a set of services and design manuals, etc., and a lot more documentations, which are the recommended practices. But ICAO Annex 14 is the visual aids. Chapter 5 in there is the visual aids, and it's currently at edition 9. So what does ICAO say? Now, interestingly, what happens is that if you get poor AGL performance, like, for example, when we're looking at AGL performance, where there are percentages of lights in a system that must be working, but there is requirements in terms of the candela that individual lights have to meet. So in principle, we can say we have good AGL performance, but what happens when it deteriorates? Robert, will you like to come in on this slide? Because I think it's an excellent slide to explain the difference and what happens in the element associated with runway visual range. Robert.
Well, as we know, as the transmittance of the atmosphere reduces, then the distance we can see reduces and the risk of an accident increases. So the RVR, instrument runway visual range, is calculated on the basis of the yellow line, solid line in the middle of this chart. So that, for example, the runway visual range of approximately, I've got all these charts at the bottom, of around about 850 meters, the transmittance is 80%, but that is dependent on the lights performing in accordance with the standards. The first thing the pilot will see when he approaches the runway in low visibility is not the surface of the runway, not the line markings, it's the lights. So it's vital that those lights actually meet the standards, and the assumed intensity is built into the IRVR calculation, which is either Poschmeider's law or Allard's law, depending on whether it's day or night. So as you can see, the runway visual range is represented by the solid yellow line. However, if the runway lighting is performing less well than the defined standard, the value that's been put into the system, the actual runway visual range will be lower, and that's represented by the top yellow dotted line. And conversely, if the lighting is actually performing better than the specified standard, the figure that's in the IRVR calculation, then the runway visual range will be better, will be higher. So in this particular example, if you have good AGL performance, you will achieve 1,000 meters runway visual range when the transmittance is 80%. and you have poor AGL performance, the runway visual range will decrease to 700 meters. So it has a huge impact on the runway visual range, the performance of the lighting. In this example, it's 300 meters of visibility. Is that clear, Keith?
Yeah, thank you very much, Robert. Yeah. But that's interesting, isn't it? Because, if we are looking at the human being, the pilot, whether it's he or she will be looking at firstly the approach lights, and then of course the threshold. They'll be following the PAPI, coming in for the correct glide slope, etc. And then hopefully they will see either the runway edge lights for category 1 or the centerline light in Cat 2, Cat 3, and the touchdown zone lights. But if there is a difference in that visibility of 300 meters, how far has that aircraft traveled at 150, 200 kilometers an hour, before a pilot can see the lights? So this is the importance, and this is the key aspect of this slide, the importance of maintaining our lights to the correct light output standard. And I think it's an excellent explanation, really. And I think everyone should really be looking at this and saying, are we, when are we doing maintenance? We hopefully all our lights are 100% plus, and our systems are 100% plus. But we know that's not real. The reality is, as soon as we've installed a light and set it to work and commission it correctly, and we walk away, it starts to deteriorate in any atmospheric condition. So as it deteriorates, we know that we start maintenance when in a system, a lighting system at 70%, but it is not unserviceable as a system until we get 50% down to 50%. But in the US, it's defined as 70% as unserviceability. So this is a very, very important slide to make us understand, but whilst we may understand as maintainers, do the operators understand? And that's a key issue, because access issues, are a factor. Whilst we want to do maintenance, are we allowed to do maintenance? And this shows that if we are not allowed to do maintenance, very, very quickly, a system could become unserviceable.
When I was a young man, I just remember it. It's 50 years ago this year. And I went to some of our international airports in the UK and found, just using simple photometric equipment, found the situation was just like that top diagram. Substandard, very substandard. And I would, a bit of a dig, say that all of them had been flight tested by the Civil Aviation Authority and deemed to be serviceable from flight. Okay. And it took about 20 years before we moved to where we've got to now with TMS started that journey. And if you haven't at least got that solid white line, then you're not compliant with the international standards, and you're breaching part of the safety stuff that regulates safety, what operation is taking place.
Yeah. Thank you, Tony. And I think this is that basically, we come to the consideration that also, when we're looking at our lighting as a package, we have runway-related lighting, taxiway-related lighting. When we've got runway-related lighting, that's a combination of the approach system. The approach is the approach lighting and the PAPIs. And then the runway itself is the runway lighting system, starting at the threshold, edge, centerline, etc., etc. But very interestingly, then if you have a good approach and a poor runway lighting system, then this is what it is known as a black hole effect. And this actually slide just demonstrates the fact that in accordance and as we've explained in the previous slide about distances when we can see the lights, then if we've got a good approach system that meets the standard as shown in that top left diagram of the photometric results, then they are very clear. But as we're coming closer at speed to the runway, then, and we've got poor runway lighting, then you can suddenly completely lose your visibility of the of where you're going to land. So we're following an approach. We assume that we're going to then see the threshold. We assume we're going to see those edge lights. But what if we don't because of poor runway lighting? They are not meeting the standard. And that becomes a real operational safety issue associated with that landing phase. Because remember, all flight is a potential hazard in a way. We try to make it as safe as possible, but the most difficult times and the most times when incidents may occur is either at takeoff, but principally on landing, and that's what we don't want to happen. So approach lighting and runway lighting are a package, and both must be equally serviceable.
Can I say something at this point?
Yes, Tony.
Illustrating precisely in a sense why I got to be starting this work, because 2 or 3 years earlier, 1969, there was a bad accident at London Heathrow where just this situation that we now understand occurred. The runway lighting was rather like the bottom slide there, poor runway lighting. It was a Vanguard aircraft making an approach. He got good visual references on the approach lighting. As he got to the point where he started seeing runway lighting, distance you could see ahead rapidly decreased. So what did the pilot do? He assumed that the aircraft must be pitching nose up, and so the lighting was disappearing below his cockpit. So he pushed down and flew into the ground. In fact, flew into Terminal 2 at Heathrow. It was a major accident, 1969. Whether you can still get a copy of the report, which was a very detailed report about it, published in about 1970, 71. But that, it isn't theoretical. This can happen if you don't do the maintenance.
Correct. Thanks, Tony. It's a really, that is a perfect example of where you have this discrepancy between approach lighting and the runway lighting itself. Then, as you say, if you think you're losing the visibility because you've got good approach lighting, you're coming in, you're confident, and then suddenly you find, I can't see the runway lighting. And what would you expect? Yes, you would expect nose up. So you would nose down in practical terms. And as you say, the danger is then we're going to either plow ourselves into the ground or at least touch down prior to the runway. And, so a short landing. So next slide, please, Robert. We're going to now show a little video, and this is Tony's video, by the way.
Category 3B runway, low visibility conditions demonstrates the importance of runway lighting meeting the required standard for beam intensity and orientation. In conditions of shallow and patchy fog, the pilot can make visual contact early in the approach. But for the reported RVR of 150 meters, he might reasonably assume his view of the runway would increase as he descends past his decision height. At 200 feet, the 4 crossbars can be clearly seen, and the pilot makes his decision to land. However, as the aircraft approaches the fog tops, the pilot's view of the runway decreases and then disappears completely. It is not until just before touchdown that the runway lighting reappears. The aviation industry prides itself on there being no single point of failure in the system that could on its own cause a fatal accident. MARMS provides accurate photometric information quickly and efficiently to airport operators. Photometric testing, when used as part of a preventative maintenance strategy, is recommended by ICAO and FAA as the only effective means of achieving the standards for beam intensity and orientation.
That's really good, because I think that comes us on to the little statement on the bottom of the slide, which is on each of our slides. You cannot manage what you do not measure. And that's very, very true, eh? Unless you actually know what your performance of your lighting is, how on earth can you plan and to do your maintenance? Regardless of whether you have access or not, then clearly, if you do not know what that performance is like for your particular airport, then you have a wee bit of a problem. We go back to our periodical type of maintenance planning. You know, we do it, you know, change all the lamps once a year, or we'll check lights every 3 months or every 2 months, that kind of scenario. But now we're interactive. We have tools and equipment, and I think this slide does explain, as we move into this digital world of today, where we have the capability to have tools to measure the lights accurately, repeatable. We need to, the equipment needs to be easy to use, because with this access time issues, etc. So, and if you've got data, it's like everything when you measure something, you collect the data, you analyze the data, and then you present the data. And it's once you've got those 3 elements together, then you can actually make practical decisions. And so what we do when we do technical inspections, when we do audits, etc., and discuss with airport maintenance teams, then first we look at the equipment that you've got in the field. And is it the correct equipment for your requirement? Has it been correctly installed? Was it actually tested? And was the installation package that you have on your field, was it accepted, etc.? So that's the installation, the material side. Then we look at all our processes and our procedures. And of course, when we're looking at our scheduled inspections and whether or not we've been given access, etc., and we've been able to correctly adjust equipment, make sure that they're angled in the right direction. Because if I had a torch and pointed at one person, it would look bright directly into their eyes, but somebody at the side, it would look dim. And similarly with lights, if they are not aligned correctly. So that means we need access with our processes, with our procedures. But we also need to have the tools, etc. We need to have spares. We need to be able to analyze the equipment, maintain the equipment. And we know that the principle of maintenance of AGL is that inset lights get changed 1 for 1, where elevated lights tend to be maintained out in the field in their installed location. So this kind of criteria is as part of our processes and a part of our equipment, then is important. So we've got the equipment that's installed in the field. Do we have the correct number of spares available for the deterioration rate of our particular airport? Now, they're all different, whether we're in the Arctic or we're in the desert, then the deterioration rate is different for all the differing reasons. But when we're looking at the installed equipment, when we're looking at our processes and our procedures, when we're looking at all our tools and equipment, and can we operate our equipment correctly? Are they in date for accuracy, etc.? So then we've got to have us. We've got to have people. And so are our electricians. And importantly, do our operational and technical management really understand what we're doing out in the field? And that's another. Do the operators, the air traffic controllers, are they aware exactly what our limitations are in terms of, if they're not giving us access, how can we maintain and keep our equipment compliant? So they're the kind of things that we look at. Those 4 elements as shown here: installation of material, maintenance processes and procedures, tools, test equipment, product support, etc. Are we familiar, as people, with the equipment that we've got in the field? And do we refresh this information periodically? Because that's another mandatory requirement. Next slide, please, Robert.
Can I make a comment?
Hello, yes, please. Hello, Seward, you've joined us.
Yes,
Hello,
I made it.
welcome.
I made it.
Yes.
I can't see very well. I can't see very well because I had a treatment on my eye, but it's coming better. But I just wanted to mention, because it's so dear to my heart, what you were saying. You're talking about the total system. And when we talk about total systems, we talk about maintenance people, we talk about air traffic control people, and we talk about all the operations people. But what we fail in so many times, and I see this just in the maintenance team, we have a maintenance leader who understands what's going on, but nobody on his team understands, or nobody else on the airport understands all the aspects which you've been talking about. And if we're a maintenance leader, we got to remember we're not the know-it-all. We got to share it with our people and get their input. They've got to come to the same level that we do with regard to observing what's going on. And if we are such that we just, well, I know the answer to that, but I don't share it with everybody else, or this situation exists, I've seen it before, but we're not going to talk about it. You got to have discussion, you got to have time together, and the people that work with you have got to have the same concern that you do, that the system is operating properly.
On that, Seward, and from your experience in the North American market, when it comes to the selection of equipment and the installation of the equipment and the setting it to work, where have the maintenance persons been in that equation? Do you find that we observe in the international world that quite often the maintenance persons are not actually included in the project side?
Oh, that's so true. That is so true. And I can remember getting into, and I think I relayed this before, getting into one of our larger airports, coming in, and I don't know what the subject was then, but it was control systems. We were talking about control systems and measuring, and this particular airport had automatic measuring system built into it. And I asked, are you using that? Do you understand why you're doing that? I said, no, we never use that. They've never really given us full instruction in that. And when the system was put in, the only people that were there listening to the manufacturer and the designer of the equipment was the management people, not the people that were going to be using it on a day-to-day basis or understanding why they should be using it on a day-to-day basis. They were left out of the equation, and I see that happen so much. Whether there's a trend in the other direction, I hope there is. But so many of it, so many times, the people that are out there walking the pavement don't understand the reasons for why they're walking it in many instances.
I think is a very good, well explained, I think, Seward, there, and I think this slide that we've got on now kind of puts all those kind of things together, correctly selected equipment correctly installed, etc., user training, etc. The first one with involving the airfield, the electricians, even at the very early project stage, etc. And of course, the acceptance criteria. Is it demonstrated correctly? Are the maintainers, do they witness those acceptances, or do they just get told, etc.? So I think that these 3 bullet points, you've explained it exceedingly well, Stuart. Thank you very much. Thank you.
And you mentioned just then also the designers of the system. We fall really short on that one. The people that come in and designing put a new system in, talk to the people that are going to use it. They may have ideas, and they will also learn, so they'll appreciate the system when they get to use it.
Correct. Yeah. Correctly. 100%. Thank you.
If I can just add my piece. I mean, the key to this is the system is built with tolerances in it. And when it comes to installation, selection of materials, obviously we're thinking about compliance, safety and compliance, but the bigger we can make those tolerances so that the distance from the newly installed quality and the failure or non-compliant level, the better. And this goes into every single aspect of the the equipment, determining the design, determining the requirements, the statement of work, and then managing the installation and selection of the components. And so if you can improve every aspect or as many aspects of these items listed above here, that will minimize your need to have interventions on the runway to perform maintenance. So that's our objective.
Which is basically, you're collecting data. We've got the data. We analyze data, and that's reliable data that we've analyzed, and now we're going to present it. So we need to have a system available to do that. Now that system, it has to be a complete package. And so when we're looking at that complete package, we have the asset management systems available for us today. It's the equipment, and of course we will concentrate on the MARMS asset management system, which is called MARMS Engineer, but there are the higher level asset managements that airports work with, the enterprise asset management system, the EAMS as it's known, but they need to have the feeder systems. So our MARMS Engineer system is a system which is going to be able to collect the data that we've measured. We're able to look at that information, which enables us to plan and maintain the equipment, but it also, when we do our regular periodical photometric checks to check the actual output, because we're talking about lights, so are we giving the correct color, the intensity, the direction, etc., the 4 C's of AGL that we talk about, and so we are monitoring that and analyzing that, which enables us to manage. So and of course, out of that then become our work schedules. And if we have regular monitoring, regular analysis, then potentially maybe we do not have to go out onto the runway as often. Maybe in traditional maintenance methods of once a week or once a month or once every quarter, etc. Maybe we're doing too much. I don't think so, but maybe we're doing too much. But now we can do it with clear analysis and justify what we're doing, and etc.
In fact, fairly early on in the process of developing the equipment, TMS, when it was still in project phase, it was identified that, yes, by doing things this way, you could actually meet the operational requirements. You can get the lighting up to standard and keep it up to standard. That was, if you like, the objective number one. You were able to demonstrate that. But out of that came the report from the airport that was being used, actually Birmingham airport was being used as a test bed. The maintenance people then reported not only were they now compliant, but it was cheaper to maintain. So that must imply less time on the runway, as well as changing equipment when you don't and so on. But the cost, so I think implicit in that is the fact that you don't need runway access so frequently to actually do maintenance and changing lights and so on if you've got this type of system in place.
Totally, 100% there, Tony. I think you know, and I personally witnessed, you know, the development of the photometric testing and the etc. over many years. Not directly involved, but witnessed it, and it's very clear. You know, if you can capture data, the data of the analysis of the light output, and analyze it and be able to look at justifiable data, and you can then demonstrate that, yeah, you know, we don't need to do it once, once a week. We could do it once every 2 weeks, for example, and that is going to save money. So to have the tools of today that are available then is actually a cost savings. So, I mean, sometimes, sadly, people say, well, you know, I'm going to offer you a piece of equipment. They say, oh, how much is it going to cost me? You know, but I say, actually, it's about through life costs, isn't it? And
so Keith, if I could just give a couple of examples here. I mean, on the first hand, we're talking about minimizing runway time required for runway access. On the first hand, if we are able to, with digitally coming back to Airport 4.0, we're capturing all this information digitally. So now, when you get the results of, for example, a photometric test or an inspection, you're able to use that information to be able to analyze the problems based on not just the data, the input you just received, but also the historic information relating to that service and location. So you can actually plan your maintenance on an informed basis. You don't have to go and look and see what's wrong. You know what's wrong.
And it's in real time. And it's in real time.
Yes. So that's one aspect. And the second thing is by digitally collecting all this information and monitor and having all the trends and analyzing those trends, you can apply AI techniques to be able to predict when a certain situation is going to occur before it happens. So, you know, a simple example would be incandescent light fixtures. The light doesn't, typically the light will deteriorate over a period of time. And so you can anticipate when the performance is dropping based on when that light was last changed, that is not due to dirt on the fixture. It's not due to some other unknown factor. It's simply that incandescent fixture, the light bulb, is wearing out. So this is what we're talking about here, and this is why utilizing an airside CMMS asset management system such as Mars Engineer is so vital to minimizing runway access and maintaining compliant visual aids.
When you're looking at the other element, so rather than just looking at the what's out we got out in the field in terms of compliance, and what about all these tools and test equipment, etc. And one of the key aspects is, can you get the spares? I certainly know that from my aircraft engineering days, I had with helicopters. At the time on helicopters, I remember looking at some guys, maintenance guys, and they had a wonderful T-shirt of this military squadron, and they said, we have the technology but nobody will give us the parts. And I think it's so vital to have that adequate stock available. And of course, tools and test equipment that we have need to be calibrated regularly, and the yearly cycle of calibrated equipment, etc. But as you just said, Robert, they're with the asset management system of today, such as Mars Engineer, then you can make reliable, justifiable decisions associated in how often and what we need to do, and that's leading us towards predictive maintenance. And when we're looking at predictive maintenance, maybe that is where we can justify that. For example, if we cannot predict the cycle of deterioration, then maybe we need more people. But if you can predict, maybe we can have the correct number of personnel in our maintenance teams. And of course, then it leads us on to then those people do need to have adequate product training, and they need to have the availability of after-sales support. Not this, oh yes, we will come out and you know, next week. Well, next week's too late, isn't it, etc. And when we're looking at those people and those resources, do we have the competent staff? And I said earlier, right, ICAO defines what competency. Competency is having the knowledge, being able to apply that knowledge as a skill, but also the human factor element of that. Are we fit for purpose in those three areas? And the training in today's day and age, you shall do training, you shall demonstrate your competency, etc. And of course, and that means not just the electricians, the people who are operating, the operations department, the air traffic controllers who are actually looking after the aircraft themselves. So all this is all part of the competency, the resource issues. So next slide, please, Robert. The interesting thing about competency is that Annex 19, I said there was, right at the beginning, in terms of standards, there are 19 annexes. It used to be 18, there's 19 annexes now, and 19 is about safety. And in the, when we're looking at safety, then there are 8 critical elements that has been defined, and one critical element number 4, talks about technical personnel. The state, that means every country then shall establish minimum qualification requirements for the technical personnel performing safety oversight functions. Are we performing a safety oversight function in AGL? Obviously we are, you know, because if our systems do not perform, then it's a safety issue. And we need to provide appropriate training, which is initial training and recurrent training, to maintain a competence to desired level. And they shall implement, states shall implement a system for the maintenance of training records. That is in the standard. You cannot get away from that. So we've put together a training programs associated, and it's called competency-based training and assessment. Now, ICAO in their standard recommendations then produce an ICAO document called 9981, and in part 2 they define exactly what they mean by competency-based training and assessment. And so we've interpreted that into a flow chart where we select people to join our team. And remember, in AGL, we're electricians. That's who we are, at different levels of electrical engineering, but we're electricians. And therefore, we have electrical training. So we've got to define ourselves as an electrician of some level. But most of our training is done on constant voltage. But most of our AGL systems around the world are constant current, subtly different. And we have to think differently. And therefore, because we have voltages up to, potentially up to and including 5,000 volts at 6.6 amps. And therefore, 6.6 amps current kills, voltage burns. That means it's dangerous, potentially dangerous. So we have to have safe working procedures in place. But we have a process now where we select electrical people, but we have to convert them to AGL technologies in terms of constant current, in terms of their knowledge and skill, etc. So we have the initial training, which we call technical training stage. We have a qualification. So we got initial training. Then we have qualification training, depending on your job. Are you a designer? Are you an installer? Are you a maintainer? Are you a regulatory person? Are you an operator? You know, etc. So different levels of qualification training, but periodically we have to do continuation training, commonly known as refresher training. And also we have to have the availability of being able to help a person in their career path. So their development training. Products change, you know. For example, we've in more recent times, we're migrating or have migrated from incandescent, which is the tungsten halogen lamp, to LED. When we're looking at the control system, we've moved to more modern communication techniques. We go to ILCMS, the individual light control and monitoring system, for doing the follow the greens for surface movement guidance in the taxiway systems, etc. So in all this, we need to have development training, which is basically associated with system and product training, or an advancement in a career where you go from the electrician on the ground doing the work to be the supervisor to be the manager, etc. So we have put this process, and this is unique, by the way, this process in AGL. This is unique to TMS Training Solutions. So okay, and a little bit of a punt there, really, for our training courses. So then let's go on to this, the asset management system, you know, into this AI world, this digitalization world, the MOMS Engineer Asset Management Software System. It's independent of a supplier. Now, that is really, really important. Suppliers do use the equipment, by the way, and suppliers use both the equipment in the field and the equipment in the workshop. So let's not divorce ourselves from the equipment suppliers, but as a company, the MOMS Engineer is an independent asset management software system. Very, very important. So how can you be the policeman for your own product? Your policeman needs to be independent. And that's principally when we are using the MOMS photometric suite of tools and bringing them all together in a management system, then which is independent of any airport, independent of any supplier. Very, very important. Next slide, please. So I package this all together, and it's coming back to the aspect about measure, maintain, monitor, and manage. And this is a combination, a collusion of the equipments that are available, the tools, the suite of tools that are available to enable us to achieve those four functions of measure, maintain, monitor, and manage. So if you want any more details, anybody wants any more details about that, please contact TMS. Next slide, please. So what are the benefits? Well, when we're looking at today's day and age, we're in this green area, aren't we? You know, climate change and everything that's going on. So what if we can reduce CO2 emissions or assist towards reducing CO2 emissions by having reliable, compliant equipment, then that means that the aircraft, there's no this unnecessary aircraft holding. You know, when we know very well that when we fly from A to B, we arrive at the airport B. In the air, we go into a holding stack, and to get for our slot to touch down, to approach and touch down on the runway. And I know I've sat in a stack for 45 minutes, which means is a lot of CO2 emissions going out. So compliant equipment is going to assist towards that. If we are looking at the low visibility element, and if we have reduced light output, then we have got to have a wider separation of aircraft in the sky coming in to use our facility. So if we could help to reduce that separation distance because we have reliable, compliant equipment, then we're going to increase the airport capacity, and our executive management are going to be very happy. They're very happy, which means less aircraft delays and less go-arounds, etc., and potentially less diversions, and ultimately safety. And excuse me, but one of the elements which is, and we haven't discussed it here, and we have in previous webinars, is the accuracy of the RVR, the accuracy of the RVR equipment and the determination of what those low visibility levels are, and we don't want to have an incorrect statement in the IRVR, the instrument runway visual range readings. Not going to go into the details, but providing we have good visibility, then we can, there's something called in the industry, in some airports now will be operating it, have what is called IRVR credits. That means that they are demonstrating that the accuracy of the AGL is higher in terms of performance than is built into the IRVR standard readings. So we can demonstrate reliability, accuracy, better visibility conditions. Next slide, please. Here is a now we talk about access. We talk about access. This is an international airport in the Middle East, and I think you can read where the equipment is. Now they have they have high intensity in terms of aircraft and landing and taking off. So the density of aircraft is high, very, very high in terms of density. So the intensity of how the runways are being used is very, very high. And so what they have decided is that their access size is minimized. So here you can see they've got multiple tools to minimize the effect on operations, and they found that of course in being able to access and do multiple tasks, multiple photometrics, then they minimized access time. But of course, you know, whatever you do, if you're collecting data, you've got to analyze the data, you know, so you collect it reliably using reliable equipment. You then collect, you analyze it, and you present it so you can make these decisions. Next slide, please. So anyone got any additional comments from the team? I have to say, unfortunately today, Carl was not able to join us because he is actually out on the road at the moment. Seward has now joined us. So Tony, Seward, Robert, do you have any additional comments, or are there any questions that have come up which has come up from the you know, the participants and or from yourselves?
Keith,
Yes.
just so I can return us to the normal screen. Yes, there's some points I'd like to make. Can I just introduce to you the we have there is one more slide, and that is, if you could just note out there that we have the final TMS Tuesday of the year on 19th of December, same time as usual, where we will be doing a recap of the airfield lighting issues raised in 2023. We will also be talking about airfield lighting competency requirements, requirements and how to maintain compliance. And we will also be doing a prize quiz for you all. So that should be a bit of fun. And finally, we'll round up with the key developments to look forward in 2024. So we'll try and make an entertaining wrap up for the year. That's going to be on the 19th of December at the same time. So panel, please.
Will you be explaining some of the potential advances in Mom's engineer at that period? Because certainly I know that you've made some advances in the capability of Mom's engineer. Right?
Yes, and yes, indeed, and what we're trying to do is obviously gear up to the challenges we're facing as an industry. So, if I can stop sharing, then we can see everybody. One of these examples might be when one conducts a photometric test, it's very difficult to sometimes it's difficult to get access to do the maintenance, but then to repeat the testing can be very hard indeed. So what we've developed is a solution called rapid serviceability. So if you test your and again, looking at the analysis of faults on runway lighting, one of the major issues is people replacing a bad light on the runway, a light that has failed its photometric test, with a light from the workshop that is already below the standard required. So you're replacing a bad light with another bad light. Because, you know, the fact it still works is neither here nor there. If it's not, doesn't reach the main beam intensity and orientation requirements specified in the standards, then it's not a good light.
So what you're saying, Robert, is that the recommended process for maintaining, for example, an inset light in the workshop, then there should be a prescribed standard for photometric output prior to a light being returned back into the field.
Yes, and one has to be practical about this. Clearly, yes, a light has. ICAO specifies a light maintenance should be performed on the light when it falls below 70%, and if that is more than just cleaning it, then it will normally require replacing the light on the runway, taking it back to the workshop and fixing it there. Now, when you replace that light on the runway, you would expect to put one in of a high standard. So certainly about 70%, but 70%, if it's 71%, it's clearly it's going to a bit of dirt, and it's going to be uncertain. It's going to be below the maintenance level, virtually immediately. What you want to do is make sure that light is certainly higher than 100, but potentially 120, 135% to actually give you some margin, some leeway before further maintenance is required. But as you said in your presentation today, you can't manage what you don't measure. So when you do the maintenance on that light, it is essential that you measure the light output before you put it back out on the runway, use it again on the runway. And what we recommend is if you tag that light, and we're talking about asset management of individual light assets. And now that individual lights can be costing, I've seen lights, I was talking to somebody about lights, runway lights costing €1,500 last week. These lights are getting very expensive. They need to be treated like individual assets and managed. That's right the way from when they're acquired, and they should be tested, and then they should be warranty period should commence on installation, and so you can monitor it throughout its life. I'm often asked, what should the standard be on refurbishing a light? And this will unfortunately probably be limited by the potential of that light. So some lights, some older lights, you cannot, if you set the standard at 90%, that's probably the best you could expect. Ideally, you would set it significantly above 100%, such that you have a good margin of use before it requires further maintenance at some future period.
So it is now back online.
Okay, something happened here. What I was going to point out is that we've had a long-standing problem here in this country, whereas we have a failure of a component, it goes into the workshop in this instance to be worked on, and the component that is used to replace the failed component is one that has not been approved with that fixture during the testing process.
So it's not an OEM. Yeah.
It's not an OEM, and we saw this immensely in signs. Signs that would deteriorate, the colored signs would deteriorate, and some airports have a sign lab, a sign manufacturing facility. So they would, based on what they interpreted the FAA standard, they would make a new sign panel and put it on the sign, which when they were done, it did not meet the performance requirements of the FAA standard or the ICAO standard. And we had that with lamps also. Lamps, like you said, are getting very expensive. And so now instead of going to the manufacturer or getting a lamp, which we know has been tested successfully in the fixture, we go to some cheaper source and put it in, and chances are they don't even test it in the workshop where they're working on it. So that's a real new emphasis, and that's where there's a real need for us to concentrate on.
Thank you, sir. I would fully support what you're saying there. Right, you know, having been working for a supplier in the past as head of service, and of course there was when reports of non-compliant equipment coming back, and then we found that non-OEM component parts had been used.
Yeah, I remember being part of a meeting of the visual aids panel in Tokyo, and we went to Narita. This must be early 90s, and their workshop there was quite amazing. It was more the cleanliness for a start. It was like an operating theatre, not a garden shed, as so many tend to be mud everywhere. But their procedure was that a lamp came in as failed, then it went through a process and would only be put on the shelf ready to be installed if it met at least the ICAO standard for output and beam spread and everything. It had to be compliant with that standard, otherwise it wasn't put back on the shelf and used again.
No, I think this is a criteria which, of course, you know, it needs to be looked at pretty closely, and certainly if we can capture that data and using the tools of today, then we can readily put those, you know, that criteria in place.
As Keith and as you've all been saying, there are any number of criteria that can be improved, starting with the design, the selection of equipment, the installation efficiency and effectiveness, and then the maintenance in life, and also the support you get from your operations and ATC people. All of these things can be improved. Some things you may be limited with, but you know, facilities, as you mentioned there, clearly are a key element there. And investments in facilities do not cost runway time, do not cost runway access, but they will benefit by improving runway availability because of the benefits that are derived from improved maintenance. So there are a lot of things there, and we're happy to work with individual airports on a case-by-case basis to help you identify them.
Well, that's certainly one of the things, Robert, that you know, that the TMS group offer is, of course, technical advice and technical inspections and audits. You know, like in the same way as the training side, you know, where we do a training needs analysis, we can assist also with maintenance audits also, you know, and to give advice based upon having the wide knowledge of collating data from many airports in all the different regions of the world. And of course, performance is different depending on whether we're in the Arctic or the desert, isn't it?
Absolutely, yes.
Yeah.
And of course, don't underestimate the benefit of networking, because, you know, a lot of your colleagues, people on this call, other airports in similar conditions. So I'm talking about traffic conditions, runway conditions, environmental conditions. They face the same challenges. So if you're thinking about installing in inset fixtures on your runway edge in a particularly cold environment where you might have a lot of ice and snow, speak to another airport that have already done it. Learn from their experience. Find out what works or what doesn't work. Do you put a heater in them or not? Are the benefits from them not being knocked down by snow plows worth the additional work in keeping them clear? All of these things, can be answered by us and by your colleagues who have experienced these firsthand.
Well, I think this demonstrates I think the panel that we have, on the TMS Tuesdays, when we're looking at the ICAO world and the different areas of the world in the ICAO world, when we're looking at the North American in terms of the FAA and all the regions associated, linked to the FAA standards, because it's not just limited to North America, etc. So we are, we have quite a combination, and principally, where I know when I get a call, if I don't know the answer, I can usually know somebody who will know. Hence the networking. I think that's coming now. Look at we kind of run over 10 minutes over time, Robert.
Yes, so we've come. So thank you, everybody. Thank you, panel. Thank you, Tony. Thank you, Keith. Thank you, Seward. I really appreciate all your effort and participation in making these happen. To the audience out there for joining us today, I can tell you that the panel put an awful lot of effort into preparing these presentations, and I hope you find them useful. I should also thank Felicity and Damon, who actually behind the scenes have put this whole webinar together. So thank you all very much. I look forward to seeing you again on the 19th of December, when we will hold our Christmas special. I've just seen another question come in. If we will take these questions offline with you, we will not ignore them. We will answer them. But I'd like to thank you all so much for joining us today, and look forward to seeing you on the 19th of December. And until then, I wish you the very best of health and happiness. Thank you very much. Goodbye.